Welcome to mathsmaster.org. Let's learn about angles in polygons, in particular interior angles. Interior angles are just the angles inside any polygon. So here I've got a regular pentagon and I've coloured the interior angles in blue. That's just the angles inside the pentagon. Everything that you need to know about interior angles in polygons can come back to one angle fact, really. It's the angle fact that interior angles in a triangle add up to 180 degrees. If you can remember this one angle fact, you can use it to go on and work out lots more angle facts and solve lots of angle problems to do with interior angles in polygons. You may already know the angle fact that interior angles in a quadrilateral, that's a four-sided shape, add up to 360 degrees, but let's have a look at where this actually comes from. What I've done here is draw a straight line between opposite vertices on the quadrilateral to split it into two separate triangles. The red dotted angles in the left-hand triangle must add up to 180 degrees because of the angles in a triangle rule. Similarly so, the red dotted angles now in the right-hand triangle must also add up to 180 degrees. So if we look at the whole quadrilateral, the sum of the interior angles in that must be two lots of 180 or 360 degrees. And that is why interior angles in a quadrilateral add up to 360 degrees. Let's have a look at the sum of the interior angles in a pentagon now. That's a five-sided polygon. I've split the pentagon into three separate triangles by adding two straight lines. Then if we look at each triangle in turn, we know that the sum of the interior angles in each triangle must be 180 degrees. So there's 180 degrees in the left-hand triangle, 180 degrees in the center triangle, and 180 degrees in the right-hand triangle. So in the pentagon as a whole, there are three lots of 180 degrees, or 540. So the sum of the interior angles in a pentagon is 540 degrees. Let's have a look to see if we can come up with some kind of general rule which will allow us to work out interior angles in polygons problems for all different types of polygons. Here I've got 4, 5, 6 and 7-sided polygons. And what I've done here is I've split each polygon up into a certain number of triangles. So the 4-sided polygon I split up into 2 triangles, the 5-sided polygon into 3 triangles, and so on. You'll notice how the number of triangles that I've made is always 2 less than the number of sides there are on the polygon. So the 4-sided polygon, take away 2, has 2 triangles. The 5-sided polygon, take away 2, has 3 triangles. The 6-sided polygon has 4 triangles. The 7-sided polygon, take away 2, has 5 triangles, and so on. Then we just multiply the number of triangles by 180 degrees to give us the total of the interior angles in the polygons. So if you wanted a word formula for this, the sum of the interior angles in a polygon is equal to the number of sides of the polygon, take away 2, and then multiply this by 180 degrees. Let's have a look at how we can apply this knowledge in interior angles in polygons questions. So here I've got a polygon and it's asking me to calculate the size of the interior angle A. This polygon is a hexagon. It's got 6 sides. So we know that the sum of the interior angles is 6 take away 2 times by 180. Or 4 times 180 is 720 degrees. Now we know 5 of the interior angles already, so if we start with our total, 720 degrees, and we take away all of the angles that we already know, we'll be left with angle A, which must be 60 degrees. This question says calculate the size of one of the interior angles in a regular decagon. Well, a decagon has 10 sides, so the sum of the interior angles must be 10, take away 2, times by 180, or 8 times 180 is 1,440 degrees. Now we're told that it's a regular decagon, and regular decagons have all sides the same length, but also all of the interior angles are the same size. So we can take our total, the 1,440, and divide that by 10 because there are 10 interior angles, and each one must be 144 degrees. That was angles in polygons, interior angles. If you want to see some more great maths videos, please visit mathsmaster.org.